Now on the last tape we got the gear blocks in. We got our spinner from True Turn. Took a preliminary reading on the weights. And what I'm going to try to do is a couple of things regarding, see, I have to make a decision here. Do I want to work on a fuselage or finish up the wing? And I don't have the little pieces of brass and the hinges for the wing, so I guess, and then Joe's going to send them later this week. And Thanksgiving's coming up, and Karen's got me running around here like a turkey with his head cut off. So I think what we'll do is work on a fuselage today. Now on the last tape, luckily we got this in the mail, and actually the delivery was a little over a week, but we're in the holiday season here in the New York area. I got the adapter kit. Now what I need to do, the first thing I want to do, and there's a million other things that I've been thinking about here. I've been thinking about making a mold for a carbon fiber backplate. That's number one, because if we're going to use this spinner over and over again, all I would need to do is order some cones then, and I think you can buy the cones separately, even if you can't. The spinners are about $35, but this adds $10 having it lightened out, and they do a nice job, of course. The only thing I have a criticism of, there's no knurling on the back. And then once we make a carbon fiber backplate mold and mold a few of these up, we can see if that's productive. Then I would take a chance maybe machining some of this away. But right now, I want to make the nose ring up. And also, the biggest thing, for some reason, they give you a steel bolt. And I'm hoping I'm going to be able to buy some of these bolts from, or just buy an aluminum bolt, or have somebody with a machine shop capability make me one up. The adapter kit, of course. But right now, using the back plate that they give us, I want to lay out a nose ring, and I want to make up a nose ring for the fuselage, and then using the engine itself, using an Novanta engine, actually get this right in place accurately. And then once I'm done with that, see, it's a step-by-step. Then I can take this piece and make up a rubber mold or whatever. I can see where that's going to wind up going. Now what I wanted to do is make this up out of laminations. This is 32nd plywood. You could use 64th, because what I want to do is get all the grains going on a different angle. And I think I'll need either 3 or 4 of these. But step one is just to trace this out. And I'm not going to cut it, of course, until I get the Now what I want to do is, from this piece, cut this out a little bit oversized, and then work it so that the next one the grain is this way, next one the grain is this way, like a clock. This way we'll get the maximum strength. Now if I just made this out of 1/8 inch plywood, the problem with 1/8 inch plywood is, even though it's got 5 laminations, what's going to happen with this plywood? It's going to have 15. Now one of the tricks to getting a good lamination, if you're using CA, just put a little bit of sandpaper on the back and leave the dust on. The dust, for some reason, whether it traps oxygen or moisture or whatever, tends to make a nice joint. Now we'll just cut another piece, but this is the primary grain going this way. I want the primary grain going off about 1/3 of the amount. What you notice, even after combining 2 laminations, because there's so many layers here now, this is really getting stiff. I think we're only going to need 3 layers of 32nd, but if it's not stiff enough, because what we want to do in the nose of the plane, we want to build as much strength, but without adding a lot of weight. Well, you know, anytime you can get stronger material, just like the carbon fiber being stronger than aluminum, you can use less of it, and consequently the weight would be less. Now, if we made this part out of light ply, the only problem is, when I've done that, in time it usually cracks at the joint or something, but these double laminations, they tend to stand the test of time a lot better. Now what I'm looking for here, I want this grain which goes this way. This primary grain is this way. I'll take this over to my flat table. I don't want to use any kicker. Take it over to the flat part of the table and just put a weight on it for 2 or 3 minutes. Now by doing it this way, we've saved probably about at least 1/3 of the weight. And this, now that we have grain going in every direction, this is really unbelievably strong. This should make a great nose ring. Next step, just cut this out on a jigsaw, and in my case I'm going to leave the line on, because ultimately when I get this spinner in place, there's a little bit of a taper to this, and I want to just run it right off. Here it is early in the day, and I'm trying to get some production done on the Royal Air Force. Oh my God, look at this. This looks so good. I just have to have a little bit. How many? What are you going in business here?
Well.
One KitchenAid. Look, I get her one KitchenAid. Did she tell you what the other night what happened? She couldn't get her KitchenAid mixing bowl apart. Oh, look at this. How does this come apart, Chris?
Oh, you want to see that too?
Yeah, this is the one that's got the Bailey's cream in it.
It does ice cream. Yeah, it still has
Oh
the
my
chocolate
God, I
sauce.
feel like I work in a
It's still
bakery.
getting chocolate sauce on top.
Now, how am I supposed to concentrate on important things like Spitfires when you're putting all this food in my face? Wait, well, I'll tell you one thing, who likes this, the birds get all the crumbs from this.
No, there are no crumbs, honey. That's it. They're done.
So you having fun with the KitchenAid? Is KitchenAid being a good boy? Okay.
You just wait.
Look at the, ooh, I love these desserts.
This to the
I'll just have to, ooh, these are good.
How do you think Dale's gonna like it?
But I gotta get back to work. Hey,
Do I think Dale's gonna like it? I don't know.
I gotta get back to work
I don't know.
in about 10 minutes.
Okay, so.
The chickadee even impressed with all the crumbs. We put out the crumbs here. Back to reality, and I'll tell you, the house smells so good. There's food everywhere. Coming up on a Thanksgiving holiday. I'm going to leave a little more than the pen line on here. Just real carefully leave a little extra material. You can always shape it back down. That's no problem. The smell of all that food. But boy, when you make up, if you can see how many laminate, well, maybe you can see it on the end of this. You've got a material that's much lighter than 1/8 inch plywood and definitely stronger at the same time. So a little extra work here, and because we know a lot of the weight, the spinner is heavier than a normal spinner by some amount anyway, until we get done with that. The motor's a little heavier, but it's on a shorter nose moment arm. So with everything combined, we're trying to still work out that we have the balance that we're looking for. Now you always get, well, at least I do, when there's a saw cut, I always get these little rough edges. I can dress them all off, and I know I'll have a 90-degree edge using a belt sander. You can see how nice and close that lets you get right up to the edge. And it also gives you that everything is a nice 90-degree. Now we know we're going to build up some of this with fiberglass cloth and paint, so if we can just maintain that line, I think we'll be real good. So you know what the pen line allows me to get by leaving that pen line on? This has a slight taper up. So it's going to allow me, once this is all final shaping is done, and this is in its position with a little bit of clearance, I can put a layer of tape on this, which will account for the thickness of the paint, and then just block sand that right around the edge, hopefully get a real nice fit. But right now with the nose ring created, I can find my exact center here and lay out how much of this I want to cut away. Now by using the back plate, I can establish the center. Now I can just use the part that comes with the nut kit to establish the inside diameter. Now using a hole template, I can get this pretty accurate by working off the center. All of these hole templates, they have these center lines, so once you can establish the center line, now what I need to do is drill this out and cut this with the Dremel saw. So this piece now is scrap. Here's a handy thing you can do, just take an old, or even one that's still got some epoxy in it, put some sticky back Bernie Trent sandpaper on it, and we could dress this off nice. Now that I have the shape pretty much what I want to do is take some thin CA and just seal this edge, both the inner and the outer edge. So it'll even make the part a little bit stronger and give me a nice edge to work off down the road. Especially with end grain plywood, it's always good to soak any end grain plywood that's showing with the thin CA. Reason is the glue that they use on plywood maybe isn't put on exactly perfect, and this is certainly going to help. I've delaminated plywood and seen spots where there isn't totally a good glue seam on it, but that's okay. We take care of that right now. Once that cures, I'll dress that off and we'll have a finished nose ring. Now that we have the nose ring, the next thing is to set it into place. And the first part of that is going to be to set this up, because the dimension front to back on this is going to be critical. I don't want to get this that it's rubbing on a nose ring, and I don't want to get it that I have a 1/4 inch gap either. Although if you have a problem, it's better to have a gap than have the nose ring rubbing. Nothing is more aggravating to me than you get to the field, you tighten the prop, and everything's rubbing and scraping and pulling paint off and everything. So we're going to be real careful to try to get a real precision fit on this front end. Now step one, this is the part that comes with the engine. This is the part we've been using, which is about 1/3 the weight. And since we're trying to get rid of nose weight, we're going to go with the lighter prop, well, the lighter part. But what I want to do is I want to be sure that, in this case, the two spacings, what I'll do is set it up with this spacer and then go in with this spacer and make sure I have the same exact front to back thickness. And I should, because these are precision made parts, but I still don't want to have the weight. It's quite a bit of weight. This part here is one of the parts on a 90 that the 90's made to run 20-inch props or whatever. We're not going to be using this. We're going to be using something, and I've got a year of I've actually got more than a year of service on this. Never had a problem. So, you know, as I'm fitting this up, here's a problem, and this is a preliminary, more of a dry fit. Here's a problem I would never have, and I'm really surprised that True Turn doesn't supply this nut knurled. This washer, the washer I have, this I think is from another engine. See, the knurls. This one flat, forget flat. This is definitely not a good choice. Even though these are nice precision fits, they've made a problem by not having this knurled. And if we were to use this, of course, I'd knurl it or dremelize it or something. But this one is knurled, so guess which one we're going to use. This one is aluminum too, by the way, which is even another better upgrade. I got my cut-off prop. I got the ring in place. It really fit on there really nice. Now the other thing I want to check to make sure before I go any further, when I take this apart again, make sure we have something realistic for a prop cut out here. I want to make sure we can put 15 and 16-inch props on here without a problem. But what this is going to do, now that I can put this in the ship, in the crutch, this will allow me to space out and get this alignment to the nose ring relatively carefully. Boy, that's a nice look. Now, one of the things that's really been a surprise to me, a big surprise, I didn't expect this to be this realistic. This really is a nice shape. And that number that I used, I think if anybody's doing a Spitfire, even a smaller Spit, this same shape in 2.5, 2.25 would probably be real close to being what you want. Boy, look at that, how nice that fits. That's just unbelievable. Now, once that's bolted in there, I think we're just going to be able to establish our clearance here, put a little filler block if necessary. I want to make sure all of the bolts are tight, that the motor's got, in our case, we're looking for about a 1/2 degree of offset, no more than that. And certainly all that's there for is to make sure we don't wind up with in-thrust when we're done. Now I can look right here and I can estimate how much that filler block, let's see, I can do it the opposite way, just measure this, figure out how thick it is, deduct, oh, it looks like a good 3/32 of an inch. So I've got to make up, I guess some 3/32 plywood would be fine for this. And then I want to space this out very, very carefully. Now it looks like, and I'm just taking a piece of, this is 16th plywood just to see how close this is going to get us. Oh, that's going to be perfect. So what we're going to do is just make up 2 pieces of 16th plywood here to extend the motor mounts out. I'll make them longer than they have to be just so I can hold them in place conveniently. So what I did, I just put a couple of drops of glue on here until I'm sure I have the setting. This is 16th plywood, grain going in this direction, of course. And I want to lay out, see now if we knew in the very beginning of this, if we knew right in the beginning that we were going to use this spinner, we could have put a little bit of a curve in the fuselage side. I'm not sure we still can't do that. I'm going to try to think of a way I can get in there. Maybe I really can, it's not a problem. But if we had the spinner in the beginning, I would have laid that out. We were originally thinking 3-inch spinner, and for obvious reasons we changed our mind. But now that we have the spinner, now we can move on to the next level of this. Now I need to put the engine back in and then make sure I've got, and I would say the minimum clearance here, the minimum is a 32nd of an inch, the minimum. Because what happens is as you tighten the spinner from time to time, it'll move the spinner back plate, bend it back a tiny amount. It'll fill up with paint, and in this case we're going to be painting the spinner also, so we have to deal with 2 layers of paint. So maybe even a little more than a 32nd of an inch of clearance. Again, one of the things that ruins my day when I tighten everything up and the spinner starts rubbing on the back plate, and I got to start using sandpaper washers and all kinds of things. It's just really annoying. It's easier to take care of it right now in the shop. Now I'm shimming this up with 2 pieces of 64th plywood, and it's always good to put a little taper on the end so they fit in. And I can feel around here, make sure I have this lined exactly the way I want it, and then just put a couple of drops of thin CA in there once I have the alignment that I'm happy with, and that should hold it in place while we put a real glue seam on it. And one thing helps when you're making up in these little shims in a 64th plywood, and all you need to do is just take some scraps, but to put a little taper on each end. So it's like I'm not sure if people are familiar with the little things that you align doors with that have a little taper in them. And that allows you to get a real precision fit, and actually you can put them all around. There's as many places as it takes just to hold that nose ring right in the location you want it in. Now we're looking for roughly a 32nd of an inch clearance. But if this were not to be true in the very end, and of course it's subject, all wood things are subject to warping and twisting from humidity and dope and changing, and what we can do is take the back plate before we put any real finish on it, take the back plate, put on some rough sandpaper, put it back on the engine and flip the prop and let it just grind its way in. But we want to do that, absolutely do that, before we put any paint on, but I'd like to get it as close as possible right now. Now what I did next is, and I thought maybe before I glue this on, I have all my shims made up now, maybe before I glue this on, I marked at the widest point where this should be. Maybe I could go in with the, well, with the jigsaw and take out a pie-shaped piece of the motor mount and squeeze the mounts a little closer, squeeze the sides a little closer together. Actually, I'm gonna think about how I want to do that, because this is one of those things where you've got to do it at the end, not in the beginning. And we're not dealing with a lot of structure up here, so that's not a problem at all. But if we could get this fuselage side to just curve in just a little bit and then glue the nose ring in, this might be worth doing, especially since we have a little time to think about how I want to do this today. This, again, when you design a plane or you come up with a design, and it's a prototype, there's always something, like I'll give you an example. On a wing, we know if we make another one of those wings, the 3 middle ribs will make out 1/8 inch light ply, not balsa. So we can get them real hollow and allow all kinds of room for the bell crank. We know in this case, if we were to do this again and know that we need exactly this spinner, and we really do like this spinner, we know we could taper the fuselage some. Now even if we had the 3 inch, we would want to taper this just a bit. So this is going to allow us, actually it's going to allow us just one more choice here that I hope is going to work out. But again, when it's a prototype part, there's always a lot of back and forth, back and forth. If you're building a model that's already been designed, built, a Nobler, a Thunderbird, it goes together in 1/10 the time, because you don't have to backtrack and change patterns and refigure things that pretty much are already figured out by the time you're building from plans or a kit. Now with the engine out, I know the spinner is going to end here. I've made a little mark. So I need to account for the fuselage side shape to see how much of this I can take out. And I probably could, this is just going to be a rough little amount. And I should be able to bend that over. In other words, I'm going to use that, one of the ribs to get that curve. And I'm going to try to look at it in terms of how does this curve look as I go behind a spinner and pick up the part of it that has the curve I want, since this is a spare piece right now. And we already have some idea, and we know we got to allow a little bit extra for the ogive. Let's see how that, if I pick that up, and actually it's working pretty well. Right about there is where I need to pick it up from. And I know this is going to be the spinner curve. I can interpolate this curve out into the part. Now just by looking at where the outside piece is, I know this will be where the spinner, I have to break a piece of this off and get it in further. Because it's from this point on, and this kind of allows, semi-allows for the ogive. We'll have to redo these because that's going to change that spacing. Well, I can pretty much see now. Let's just see if I can interpolate this. And I hope that allows for the ogive. Now after looking at it from the top, I realize I made it too short. So I'm going to re-interpolate this. Just add some thickness to it and go in between the second line. So yeah, that's why I like to see things in full scale. I really don't like playing, and when I see it in full scale, I know what it's going to look like. Same with this spinner. If we just had an outline of this spinner, I don't know that I'd be this confident that we're going to get this Spitfire nose right. Now what seemed real helpful here in estimating the ogive, because again, this is not a straight curve. A little piece of green tape seemed to work pretty well there, and it's given me just enough of that Coke bottle shape. I think this is going to work fine. Now, because I can lay this down on the bed of the Dremel saw, I should be able to get a 90-degree cut along this edge and along here and just re-glue this. We'll see. Now for sure, anytime I'm cutting motor mounts or hardwood, I always try to use a new blade just to get a nicer cut. And it seems like here in the shop we go through these blades like water. I'm not sure if there are it's because they're not that good or because I abuse them. Not sure, but I want to try to check the table, that the table's 90, to try to get a nice even cut on this. But of course, because we're prototyping, yeah, this is a hard way to do it, but well, we're going to find out if this is going to be worth the effort that we're putting into it. Now I'm going to try to maintain that 90 degrees on the cut. Now, if this were a nose without an ogive, this would be a straight line. It would be not a problem, but we're trying to get that curve and then into the spinner. Just a little tricky. And this one is right up against the doubler. Okay, now we have a piece missing. But now I also want to cut in between the doubler and the side so that that's going to be able to lay over better. So what we've got is the piece missing. And we've got the slit between, well, between the doubler and the, what am I saying? The doubler and the fuse side, so we can peel that over one part at a time. Let me do the other one off camera. Now, having that one piece, I think that's going to be, well, we're going to find out. It's going to make doing that ogive just a little bit easier. And there's still a little bit of rough edges from the saw cut here. This is one thing good, a machinist ruler with sandpaper on one side. And I think we've got it right, but I'm not going to know until I put the whole thing together, of course. But what this is going to save us is a lot of work when it comes to shaping the top block ogive into the spinner for that fit that we're looking for. And I think anytime you induce a curve into something, it's just going to get stronger too. Okay, now to glue, I already have the doubler in there. To glue the side on, what I'm doing is putting a little glue in there, using a piece of 64th plywood, spread the glue. Now all it's left to do the other side, of course, and see if, when we put it all back together, if we have that ogive shape we're looking for. And now, once these are done, to re-true up all the edges, and then we're going to have to refit that nose ring. Now some of this may have changed, and we're going to have to, of course, re-shim the nose ring. But we haven't really touched the part that matters, and it looks like we're just going to have enough here, and maybe not quite enough. If we have to cut this too thin, obviously we'll have to put a little spacer in the inside, which is not a big deal to do. But the next thing is to true these edges up. And then we'll be ready to refit the motor and refit the nose ring. And just kiss this, make sure we're got nice and flat. Now I don't want to sand any more of this in because we're looking for that ogive. And I'd rather have a little bit extra material. I really didn't want to get too cute here and get this too thin, because we do need to get that shape for the spit. Now it looks like we're close. Boy, I'm hoping we are. We're right about where I would suspect this little reverse curve should be. When Joe makes the top buck, he'll be able to curve it up ever so slightly. It's shimmed back just about the way it was. Now what I'm going to do is just put a couple of drops of CA in there, just to see if this is going to stay in alignment when I take it apart. Now I'm taking a little shim. I want to make sure I have equal clearance. I don't have it hanging up anywhere around the perimeter. Using my hand, I can feel that we've got it right on the money, I hope. And I just think all of the work, and this basically was a lot of work getting this nose ring in place, but I think it's going to really pay some dividends in the final shape and when those valve covers are on there, and how this is going to blend. Not a straight curve again, it's going to be just a little bit of a swoop there. You can get a little idea how that clearance worked out there. Now this is going to be a tricky thing to figure out because the top here will blend into the ring. Not worried about that now. But as this piece comes up, I'm trying to figure out how much of a doubler I'm going to need in the nose here. And it looks like I'm going to need a doubler right up to the first engine bolt, because this is going to curve in. It's part of the ogive as that goes in. So I can estimate right, I guess, just about up to the first engine bolt is where that's going to end. Anyway, I got to pull this all apart now, and then next step on this is going to be to make up that doubler. And actually it'll help support that nose ring a small amount anyway. And one final thing is I wanted to try the other thrust cone just to get some idea if we still have the same clearance. And that looks fine. Now the first thing before I even lay out those doublers, there's a little spot here I need to just fill in with a balsa plug. I'll just rough out a piece of scrap, fill in that little divot of an area there. I just made some little plugs, waiting for the CA to be sure it's kicked off. Then I'll trim and I'll sand it right up to this line, blend it into the nose ring. I don't want to change the shape of the nose ring, I just want to use it for a guide. And making up a little pattern from the scrap piece that's left over from the fuselage side. Because what's going to happen, I just want to have a little more material here so I can curve this around. Even though I don't think I really need it this far back. In fact, I can shorten this a little bit. It really is only going to need to go maybe up to the beginning of the motor mount pads. It doesn't need to go that far. And then I want to put a taper in it. Before I even glue it in place, it'll be easier to get a taper on it. and then I'll have a pattern. Now we'll be able to take even more material out. Once we get the final shape, then we can get inside of this and even take some more. But letting that have a nice little taper in, be just a little bit easier when we go to do the final hollowing out inside that engine area. And that's just going to give us just a little bit extra material, reinforce the nose ring a tiny bit more. Now make up the other side, and then I'm going to relieve some of this wood out of this mount area. We don't need to have the mounts any bigger than that, that's for sure. Now with both of them in there, I can true this up. And I've got just a little bit of reinforcement there. And once I have that edge trued up, then of course I'll seal that to harden up the edge. And we'll be ready to cut some of these motor mounts away. I just heard from Mike Kajeski while we were off camera. He's finishing up this closet that we did for the kids. And we're going to be doing the shelving on it probably in the next couple of days. But if you haven't gotten your wife a nice Christmas present, believe me, they like kitchen aids and closets. And it gives us a nice little taper in there and a little reinforcement. I'm just trying to get this neatened up in here. I think we've left enough material up in the front here to make a solid nose ring. And any weight we can get off the nose, it's all going to pay. It's going to pay somewhere down the road. And this weight up here, this material is just going along for the ride. And that's always the challenge in prototyping up a part is see where you can get material that's just going along for the ride. And all little sanding tools that we've been making, every one of them right now is just like having an investment in good construction. So that worked out pretty well. And one last thing I may be able to do before this day ends, because Thanksgiving's coming up, of course. I wanted to lay out and see if I have a scrap block big enough. I need to measure this at its thickest point. I'm thinking of doing this in two pieces. This piece, and ending it here so that the cowl will be one piece, allowing us to take it off, and of course without having to take the header off or anything off of the motor. So I'm just going to try to figure out if I have a block, a piece of scrap that's even bigger than this, but I also have to take into account the width here too. This is wider than what we normally would be using, but let me go out to the scrap and see what we got. I got a beautiful piece here. I don't know what we were saving this for. This is like 20-pound wood. But anyway, I can lay out, I'll work right off the pattern here, roughly what shape we're going to use. And I'm going to need three. Here's the problem. I'm going to wind up needing 3 laminations because 2 are not going to do it. 2 are just going to be too thick. Maybe I can put 2 pieces with like a 1/4-inch piece down the middle. Well, we're going to have to figure it out because we're coming up on the end of the night. But I thought if I could at least get a pattern cut, get some of these cut out blanks. I'll make this. This is going to be it for tonight. I'm going to cut up another block, see if they're wide enough. I've left it plenty oversized to what we want because I want to be able to vary the shape here as this shape starts to evolve. So I'll cut another one out of there, and that's going to be it for tonight. I see we're just excuse me. We're just a little bit too sneezy here. A little bit too thin. I'll look for a piece of 1/4-inch scrap, run that down the center, because that joint will ultimately be easy to bury. And even though this is going to be a plug for a mold, so it doesn't really even matter if we get it right or not. We're going to put primer and air epoxy and everything, but it's just a little bit, 1/4 inch too thin. But again, when you got scrap blocks to use up, well, that's all we're going to get done tonight. It's the day before Thanksgiving. The house is full of the smell of all kinds of food being prepped. And tomorrow we're going to have our whole family here, so it'll be nice to know we got the cowl blocks ready to do the joining and roughing out. I'll be starting to think tonight about how I want to make the mold. I could make the cowl in 2 pieces, well, not 2 pieces, but just a Strega type of cowl, or I could, the problem is if I put this piece of cowl, if I attach that piece to the fuselage, the problem is how do you get the motor in and out with the header? I got to think about that. I got to think how that's going to work out. But again, this is a prototype plane. It's evolving. It doesn't jump off the plans. The second one or third one would jump right off the plans. This one requires all these little adjustments. Now when Karen and I woke up Thanksgiving morning, it's like 60 degrees out here. Of course, haven't already cleaned the leaves. We've got another day of leaf cleaning to do. But what a fabulous Thanksgiving day this turned out to be. I'm sure all the hogs are up there flying, but I only have about an hour here, so I'm trying to pick a little project that would take about an hour to do. Oh, the wind's already blowing. It's early and the wind's already blowing here. The leaves are coming down like crazy. It's a typical fall day here in the Northeast. Now as I go to the box here that has all the old molds I'm looking at, Mike Kajeski was already here this morning. Mike's old cardinal mold. This is one of many drawers we have. The plugs. And I know Rich Walbridge is wanting to make a Seafire cowl. So here's one of the things you can very conveniently do is, see, I always save the plug that the mold is made from. By saving a plug, it really works to my advantage now, because he's practicing on an old mold I sent him. But we can always recreate the mold. And we've got a couple of these that I like to have. Oh, these are the old Seafire exhaust molds. Don't want to lose that. And see, the thing is, now here's the Seafire plugs. I've still got all the plugs. So that's going to be nice when it comes time to do that. Of course, if you remember, we used to make carbon fiber bell cranks. They didn't work out like we wanted to. The ones we have are lighter and stronger. We got the scoops. But here's what I'm looking for. This one's, you can see this one's chewed up. See, these get old quickly. This is one we were making. We were making production parts for Randy Smith. These we were making 4 at a time. But what we're going to do, we're going to make well, you can see how many of these I've made. Here's what I was looking for. This is the one I wanted. This is the mold that we were making for True Turn for their spinners. Now, we ran into a problem with these. If you didn't use the high temperature resin, if you try to use EPON or try to use some other resin, these weren't quite as durable. So what I'm going to do, I'm going to make up a mold while I have the part in my hand. Here's some we have for 2 1/4. Boy, I never realized how much junk I have in this molding drawer. One of our original. I'm going to keep those all together. Some of the ones for the 5-bladed props. Now whenever we start molding, I always go back to some of my old molds just to look at, because I forget this stuff. We were making hundreds of wheel pants at one time. Here they are. Here's the original ones that we were making. Here's the original. That's what I'm looking for. Now we're going to make pretty much the same thing, but we're of course going to use the bigger diameter back plate. Isn't it amazing how many things you accumulate over the years? Here's what we were making. Here's the Spitfire one. Look at this, the original Spitfire one. And by the way, if Rich Walbridge wants these plugs and he wants to make his own mold, we're going to go through it step by step. See, I'd always rather people learn the skills. Here's one of the bell crank molds. If you see the technology and you know that you can do it yourself, here's the landing gear mold. Look at this. Wow. A lot of good memories in these drawers. Anyway, we're going to add to this, and we'll probably at the end of it have something to put back in a drawer at the end of this Thanksgiving Day. Okay, now this is the big back plate. It's got a little spacer in here, and what I need to do is get the spacer even with the back. It's a press fit. Step 1 is we want to have the back of this perfectly flat, because that'll be the one side of the mold. So I want to get that spacer. Now a lot of times obviously you wouldn't have that spacer. So to get that close on one side, that's step 1. Now the flat part of this I want to have dressed off as relatively smooth, because I want it to make a nice mate with the base of the mold. The rest of it is pretty well polished, but if it wasn't, it would be to my advantage to polish it so that the parts would release nicer. But with a rubber mold, with the technique we use for the rubber mold, I think pretty much anybody can do this. And this is as easy as it gets. And if you go back to the original Spitfire, where I was molding parts and spinners and I was kind of learning the trade 101, it really took me a long time to figure out a lot of these basics, but now that we know them, it's really not difficult to do this. Everybody, if you pick this up step by step, should be able to make their own parts very conveniently. Now the next step on this is just to take a piece of scrap balsa wood. The thicker the better, so it doesn't have a tendency to warp. None of this is fancy stuff. This I know is a relatively smooth part here. And what we want to have is, when we're all done with this, that this part is flat. Now what I'm going to try to do here, and very conveniently of course, put a little bit of pressure on this with my finger, because I'll be able to take the balsa wood off at the end of this. Let me give you a tip. Now, again, pressing it, trying to get it centered. All I want to do is seal around the edge. Now, let me get a couple of Q-tips here. I don't want any on there. This won't matter. I seal that edge as good as I can. Now by pressing this down, what I'm trying to do is create that none of the rubber will walk underneath you. Obviously what happens is in the real world, some always does, just a little bit always does. Let it kick off without kicker. Now the next step is to make, any way we can, it doesn't matter, it doesn't have to be fancy, make a box around here. Now the only reason I need to do that is when I pour the molding rubber on here, I could do this with a coffee cup. I can do it, make it as fancy as I want, but it has to be a pretty reasonable thickness so that it maintains this shape. So anything more than 1/4 inch is probably going to be fine, but we need to just create a box here. Now just using up some of that scrap 10-pound wood that we always have plenty of, I can look at this and see roughly how thick I need to make it. Even less than the thickness of a ruler would be fine. Now the little trick that I learned, and it's really worthwhile here, is just to strip off all the parts when you're making a molding box. The idea is not to spend any more time than you have to make these fancy. Is just make the pieces, it's always scrap wood, a little bit bigger, and each one goes to the next corner. Otherwise you got to try to fit these corners, and it takes a lot of time. And the idea is to get this going right away so you can move on to the next step. Scrap wood, I know this is going to be longer by 3/8 of an inch, 1/4 of an inch, some amount. I can take all these pieces now. I don't have to make them fancy. And the only thing that's important is to make them 90 degrees. Again, once we get 4 of these, we'll be ready to set up and make our box with all the edges. Each edge goes to the next corner, and then they don't have to be a precision fit. Now, of course, the idea is, whichever side you're working off, one of these had a decal on one, so you may as well use this up with the decal on the outside. What you're trying to do is just create a box so that the molding rubber doesn't go off the edge. Once one side sits in, now what I did, I put this in wrong. This piece should have been going out that way. No big deal, we'll just trim this off to fit. But when we're done, you can, well, maybe see if the glue has gone off. You can see what we're trying to do is just make a box. Now, if you really wanted to, what you could do is you could buy this little magnetic, George Venturini's son had it, that had magnetic things, and they were all made out of plexiglass, and they looked real professional. Yes, you could spend money, but the joy of what we do, or one of the things I like to do, is try to keep that the cost of what we're doing is inconsequential. In this case, it's a bunch of scrap wood. When we're done, we're still going to have the original aluminum part. We're still going to have the mold to make more parts. And see, I wanted to make the mold before I do any machining on this. That's a critical thing, because I don't know if when I machine this how light I can make it. But I know once I have a carbon fiber part, I should be just a little bit more than half the weight of aluminum. And I know we've used these. I know they're a practical thing to do. They're very labor intensive to get the toe to go through these webs. I remember it being really a pain to make these, but they're still doable. They're still something that I know we'll be able to do. And it'll give us choices. It'll roughly be, when this is done, this will be a ½ ounce off the nose. And anybody that's ever taken a stunt ship that was a little low on performance and pulled a ½ ounce out of the nose, you know it's like magic. Now the next step is just to seal the box. The idea that the molding rubber won't wick its way through. And we'll go over to the belt sander, even off the little ears. You can watch that just run into the corners. Now in some cases I want to have the back plate glued to the base plate and then put a finish on it. There's times like with the landing gear legs. Rich Jacobone is going to recreate his Stuka cowling because he wants to make more Stuka cowlings. So what we want to do here is, in this case we don't care because we're not going to take a part off of that part of the mold. And this part, when it's all done, will have to get chucked in a lathe and trued up anyway for the last couple of thousandths. So this makes us a real quick, very easy to replicate mold. Now we can just even up the ears on the box. This is really just a cosmetic step. Ready to pour molding rubber. Now the next step on this, we'll dig out the molding rubber, get some idea of how much, I just take a rough guess how much is going to go in there, and we'll be ready to pour the molding rubber. Material that we're going to use, molding rubber, this is available from Smooth On. And if you have any interest in this, I'd suggest you call this number, get their free catalog. It's absolutely free. And they tend to give you updates and things like that. But the material, and their tech people are excellent, by the way. The material that we've used very successfully, Mold Max 30, they make similar materials. And they change this from time to time. We used to use a different product. And when I talked to tech, they suggested I try this. It's a 10-to-1. 10 of molding rubber, and you can see it's Mold Max molding rubber. This is a 10-pound unit, and that's probably what's best because it's about 1/3 the price. If you buy a 1-pound or a 2-pound, you pay through the nose. What I have in my hand here is basically a little over $100 with the shipping, and you'll make many, many molds, and it's got a good shelf life. Probably, I don't know exactly what it is, but it seems like 2 or 3 years later it still makes good molds. But anyway, here's some of the tricks I've learned, and boy, this is a big one. This stuff is stains everything it touches, so you want to, when you're ready to use this, cover the whole workbench with newspaper. We want to gram scale it out at 10-to-1. And whatever part of the bench I'm going to be using, because this stuff stains, it's slimy, obviously you want to use rubber gloves. But 5-10 layers of newspaper are always a good choice. By the way, that table with the rug pad's been working real well for us. Anyway, we're going to set up now. I'm going to gram scale out the amount of material that I want to use. 10 rubber to 1 kicker, 10-to-1 ratio. Now it can be pretty sloppy working with this stuff if you don't know all the little tricks, and of course I don't know them all yet. But pouring this rubber, I probably am going to need a little more than a ½ a cup here. And it's certainly okay, and in fact this is going to get pretty sloppy, I can see that. You've got to kind of, you know what? It's cold in the shop this morning. See how this doesn't want to pour out? You know what I'm going to do? I'm going to take this and just warm it up, put it up by the heating vent for a couple minutes because it is cool in here. Even but the heating vent isn't warming this up. It's just cold in here. And maybe this is already out of code. I don't know yet. I may have to order some more if this doesn't feel. I'll know right away if it doesn't cure. But a good trick here would have been if I knew an hour ago I was going to use this, put it up by a heating vent. Just let it warm up. It just pours nicer. Let's see if this is any better. Oh yeah. I generally, whenever I'm using anything that's two-part, I like to keep the shop cool, just so it gives me more time to work with it. Now, from the way this is pouring, I'm thinking maybe this even should be warmer, or maybe this is already out of code and I don't even know it. Well, we'll use it anyway, and if it doesn't work out, see, I don't know how long I've had this because I bought another batch in between that we used for a job. But certainly if it's at it, well, this will be a good test to find out if it's at the end of its shelf life. I'd have to look through my bookkeeping records. You can see what happens. This gets sloppy at the end. Sloppy at the beginning here, as I say that. Anyway. Now that's always the trick, is to get it to stop pouring. Get some of this in there. But we'll learn something about the shelf life here, I'm sure. Now that's way more than we're going to need, but it doesn't matter right now. Make sure I'll stir this up. And the next step, we're going to have to weigh this out and then put 10% of the kicker in. See, now I have 310 grams, so I know I'm going to need 31 grams. So I can just move this to the position that would be. And then I can make sure I have this shaken up. You know, another thing too, when you call Smooth On, they tell you what a shelf life is. Look at this, I can't even get the cap off. But if you store it, there's different ways you can store it in the refrigerator and cool and hot that extends the shelf life. Well, I'm not sure that we haven't exceeded this. Again, we need to possibly learn what this, let's see what the kicker looks like. Okay, now as soon as I see that coming up on the scale, now anything that's 10 to 1 doesn't have to be accurate to within a drop. It's not like EPON or some of the other things that might need to be a little more accurate, but as soon as that scale moves, I know I've got it. There we go. And if I was way over, now the way I can tell if I'm way over is just, nah, we're within the range. Okay, now the trick is this going to mix up the way it should? And that's going to, if this doesn't, we're going to have to go to our other batch, but in this case, if this material turns pink now and it absorbs the kicker, I would be willing to bet it's going to work. A lot of these materials, if you just warm them up, actually the day before you're going to use them, get them warm, that helps a little bit too. And this takes, whenever you think it's done, you're done stirring it, give it 2 minutes more. Now you can see, this is giving me some confidence. It's mixed into a nice pink color. Some of the kicker, it's nice and it's thinning out too. Some of the kicker is light blue, some is pink. I don't know why. It's just a dye to show you that you've got an equal mix. Also, if you mix this with an egg beater, you ingest a lot of air into it, and the air is your worst enemy right now. Air is going to make air bubbles. The air bubbles show up in the mold. So a real quality mold, you want to stir it slow. And again, when you see it right now, it looks like it's stirred and you're ready to pour it, mix it another 2 minutes. Because you have basically an hour before this is going to start to kick off. And if you have a heating vent in a shop, that's a good place to just put it by the heating vent. Okay, this looks like it's going to be good. Again, this, you know, I never believe what they tell me about shelf life, because I've had stuff, paint especially, that the shelf life is limited. I keep the kicker in the refrigerator and it seems like it 3 or 4 years later it's fine. Now let me get the phone. Now it's always really to your advantage if you can let this sit 5 minutes, which we've done. I'm getting around all the edges because that's where some of the material that wouldn't have enough of the kicker in would be right around the edge of the cup. Now this is the part that a lot of people, and in fact when I started doing this kind of thing, I was frustrated because what I did, I took the jar, dumped it in. You can't really do that. What you got to do is work the mold, and what I'm going to try to show here is fill in the lowest spot first, because what happens, you can see you always have little air bubbles in there. Always to your advantage to take your time here. You want to fill in all the little gaps first, depending on the shape of the mold. And these are going to sell. It takes me a good 15-20 minutes to fill a mold. Even a simple mold like this. This is one of the more simple ones. Because at each step I want the air bubbles to rise out. Now what I'm doing right here is just putting in the thinnest layer that'll cover the part. Because I know the air bubbles are going to start to rise. And I'm going to give this a couple minutes. And we'll see the air bubbles rise up, and you'll see what I mean in 1 minute. Now I found especially the smooth-on release products, all of the products that they sell, and their tech help, I wish I knew that early on. See, I was buying this stuff from a different dealer, and their tech help was, you know, like non-existent. And when I stumbled upon Smooth-On, they really changed everything. And I think if you go back into those early Spitfire videos, you'll pretty much see what I mean. Now see what I'm doing. I'm letting this seek its own level, move it around, give it 5 minutes, because what's happening, all the air is coming to the top. A little bit of heat even helps. And what we're trying to do is get the air bubbles up off the part. And it's only the part, I don't care if there are air bubbles in the whole mold, except for where it's going to touch the part. Let me just let that settle out for a minute or two. But you can see all the bubbles coming up. And if you want to be cute, when Elliot was doing his molding, the first couple times I remember he would sit and pick away at the bubbles. Yeah, and that doesn't hurt. They eventually float up. And I found out a hard to learn lesson when I made the gear mold for the Spitfire. I had the part on the top. You always want the part on the bottom of the mold if possible, so that the bubbles float away from the part, not toward the part. Again, little things. And by the way, Smooth-On has another thing. I don't think there's anybody that well, maybe not, maybe they are. They have a course that you can take your part down to Smooth-On given weekends. I think they do it on a weekend, and if I remember right, the price was $300 for the weekend for the class. 2 8-hour classes with molding, you know, obviously high-tech guys that really know their stuff. And if you like the ultimate, want to improve your skills, in fact, I've thought about doing it myself. Just we run out of time here because we're still involved in this rental property deal. Just every day that eats up 2 or 3 hours of my time, one way or another. Okay, now I've got that much done. Now what I'm going to do, you can see this already has bubbles in it. Well, we're going to start layer by layer, like making a wedding cake. And hopefully get all the bubbles to come up to the top. That's the goal. And spinning this cup at the end, this is a good trick. See, I've got nothing drooling off of it. That in itself is one of the good tricks. Now we'll work this again. And if you do it in layers and give each layer a little time to come to the top, boy, are you way ahead. Let me just the slightest little bit of heat on this. And usually, I'm not sure always is the right word, but usually anything that's two-part will catalyze faster with heat, slower without heat. So maybe this is speeding up the procedure some, I don't know. And I still don't know if this material is out of code or not. Again, let's put the hair dryer down. I can sit here and do an Elliott. Well, Mike Kajeski, when he made his first cowling, the Cardinal cowl, and I remember we made several of them for other people too. I think Tommy Hampshire included. But what happened is, and Mike Estella, what happened is once you make one or two molds like this, from that point on you can kind of improvise and come up with your own ideas. But there are some basic rules that never change. This is one of them. The part should always be at the bottom. See, if we had the part up here, on top, if we were molding this screwdriver handle, what would happen is all of the air bubbles come up toward the screwdriver handle. Now another trick, George Venturini had a good trick. He had the carving knife that goes back and forth. It's like a vibrator or a jigsaw, and he was holding this in the same hand he was holding the jigsaw with, just to shake it. And that was the shaking itself brought all this up to the surface. But you can see each layer gets a little bit better, hopefully. Again, and you can see we still have some air bubbles to deal with there. And from this point on, I really don't care about the air bubbles. They're going to be out in the top of this mold where they're not going to ruin my day. But when they're down against the part, it means extra finishing work on the part. And if you pour a big mold, like a fuselage mold or the Testarossa bottom block mold, boy, and then you have to finish it, extensively finish it, it's sad. You really get depressed. Anyway, so what I'll do now is get the rest of this to come out. Because the thicker the rubber is, the more stable it is over time. Looks like we mixed just the right amount. That was a lucky, by the way, that was a lucky guess. Now I can see some of this molding rubber that's out at the end here isn't really mixed as well as it should be. It's got little strands of white in it. So what I'm going to do is, rather than, I'll leave that last little bit in there, rather than get too cute, we filled the box. Just try to stir in these little white areas. Put a little heat on here, let some of it rise up. I see maybe we even got a little bit more than we need here. And we'll start to let these air bubbles rise up. Now we actually have more than we need here. We could skim some of this off. And once I wipe this up, get a little heat on it. I'll be thinking about this curing up while we're having our Thanksgiving dinner. Well, after, well, tomorrow actually. That really should sit 24 hours. I'll give it even longer than that because we got other projects to work on. And if that material's out of code, we've lost nothing because we can just take the material out, break the box apart, recreate the box. We will not lose the aluminum part either way. Now, if we were doing composite parts and you don't put parting agent on them, whole different thing. You can lose the original part. But this is a very low risk operation, and even if here's what would happen anyway. We've got the old molding rubber up here, and I've got a new gallon over here. So either way, I was trying to use up the old stuff, but again, this will be a little experiment. And a lot of times I find out when I talk to the tech people, you know, and they say right on the can it says shelf life 1 year. And then you go and you talk to the tech people and they say, it's really 18 months or 2 years or something. So, again, this is something that to me, I've been doing since '96, that's 11 years. It's added to my enjoyment. It's allowed me to make parts like cowls, top blocks, fuselages, spinners, back plates of spinners. It's allowed me to make my model very much a personal expression of what I wanted, not having to use as many commercial parts, and to be honest, it's a lot of fun. Here also in today's mail, while we're just taking care of the daily business here before our lovely Thanksgiving dinner, trying to take care of the last few things out on the email, some pictures of Sergey Belko's latest model. Look at the workshop here. He's got some nice pictures of stuff in the background, nice clean work table. Now what I've been doing as I've been making the last few videos, I've been going through some of my real old stuff, and I got some really old pictures of the World Championships from a long time ago, and I've been trying to get a couple of decent scenes, something that would be neat. And I was looking, what I'm doing, I'm searching out some stuff. I want to see if I can find some stuff of Sergey Belko from years ago, but I haven't found it yet. Means it's coming soon, I hope. And yes, I get the call from Rich Jacobone. It's Thanksgiving Day, and that lucky dog is out in 60-degree weather flying. I just can't believe it. He rubs it in. He's like rubbing salt in the wound here. Anyway, we're getting ready for the last few details. Karen's setting up the table right now. Things are cooking, baking. Oh my God, it smells great in the house. And we wish your family every good blessing for a Thanksgiving also. Well, it's Thanksgiving Day in the Ertnowski house. We're waiting for the family to get here and a few choice guests. Karen has, as always, and I don't know because she seems to outdo herself each time with these tablescapes. Look at this. Check this out. Oh, we're not going to have any of that. And I know how good these cookies are because I've already had one. Honey, you've outdone yourself.
Those aren't lit yet.
I am so impressed. I'm telling you, if they had a contest for tablescapes, I'm not sure. Even the birds are impressed. Even the Graccolonis are impressed. Look at this go. That is unbelievable. And obviously our family wishes your family the happiest of Thanksgiving. All good things. All nice birds. These birds. I don't know if they even know it's Thanksgiving. Do you think they even know? Do they care? This we have the cheese platter. I think I'll just help
Not finished yet. The cheese platter's not finished yet.
I think I'll just help myself to a piece of cheese. This is going to be a hard one to outdo, baby. That's all I got to say. Thanksgiving in the Ertnowski house, 2007. Few choice hors d'oeuvres. Oh, I'm getting hungry waiting for the people to get here.
There's still more hors d'oeuvres to come out.
And the hostess herself. This is really coming out to be the end of our leaf season. The end of our decorating for fall. The next couple of days we'll have to take our mums in, our pumpkins. Oh, there's our lovely neighbor. Oh, how are you guys? Happy Thanksgiving. Hey! Look, Mike, there's only 10 million calories in that. You can never play sports again once you eat one of Karen's desserts.
Oh, no, that's her dessert. Looks nice.
Yeah, looks great.
I'm afraid to ask.
Oh, you'll love it.
What a beautiful day for a Thanksgiving. Wow. 60 degrees. Don't drop the dessert. Whoa!
Hi, Wendy. Everybody's almost here.
Everybody's almost here, huh? They look hungry to me. They look like they need... Looks like they need some balsa wood. Actually, this has turned out to be an unbelievable day. The wild hogs are flying. We're celebrating. We even got a little bit of work done on the Spitfire. You ever see so many dolls in anybody's house? The Doliachkas are everywhere. Now what happened today is Stacy and Rob were going to originally have this over by their house. but because Mike Kajeski is still, well, we're going to work on it tomorrow, finishing up their closet in the bedroom, would be a little bit too much for them to move everything around, so we just decided to hold it at Karen's. And of course Karen takes on the challenge seriously. Oh, do you go?
No, come on.
Oh, Craig in his bib.
Yeah. Can you tell? It's a famous bib.
Oh, he's got his
Very,
professional
very
chef
nice.
knives.
We do
Don't you hate people that show off, Melissa?
Yeah, you know.
Oh my God.
You know what it is? It's not,
Let's see the knives here, Kung Fu.
Oh boy. You know what? They're hiding.
Look at this. It's like having.
Outfit on camera?
Yeah, he's very attractive, very manly too.
It is very manly, and I know that you're all jealous.
Craig, it's a bit fruity.
It's a bit sassy. It's a little foofy.
Cooking for gays.
Hey.
Look at that. Ah.
No, we like,
Carbon fiber handles.
we like the way you look like this.
Yeah, we're proud of your manhood.
Brings out your feminine side.
Oh, thanks. I try to be secure. Oh, I think I'm gonna go with.
We need to eat it in a little pan, right? So it's
I'm
like.
gonna go with.
This one is my favorite.
I'm gonna go with this one and this one.
I like this one. Whoa.
That is some set of knives, my. Ooh.
Oh yeah.
Now this.
Yeah, that knife says O.J. Simpson or something.
That's right.
That's an O.J. Simpson knife.
I mean,
Oh, and the sharpener. Oh.
well, no, just.
You know, I had one of these when I was a kid. I used to play Zorro with the sword.
That's right.
Happy.
Yep.
You know what that one's. That'll work.
Yeah.
Where's the garbage?
Good ass whipping for the boy.
Over there on the left side.
Up to next Maddie. Okay.
Oh, there's more food here. Unbelievable. Unbelievable food.
I don't know, I don't care. I'm saying.
Yeah, chairs, it doesn't
He's
matter.
bigger than me, so he probably needs that, you know?
You need this.
Here, let me put this one. This doesn't belong in the kitchen.
Even Karen can have some more.
I'm embarrassed.
Take this back with me?
Take that. Let's toast the Karens.
Make us look.
A toast for Karen's retirement, Bill.
Oh, everything looks nice.
Oh, and this is Thanksgiving. No toast today.
Like that?
Don't you like having a big family, Rob, with lots of turkey for everybody?
Like everything
I got
except the
the
cameraman.
Boy, we had a great party. We slept late. The birds slept late. And it's time to go work on the kids' closet. We're going to finish this closet up for them today, and then we'll get back and work in the shop. Oh, what a day. The wind is really blowing, but boy, the leaves. Oh my God, we're at the end of the leaf season. Some of the trees are already done. Just an unbelievable time of year here. And we're going to go over and work on this closet today, hopefully finish it up, and get back to the shop. This is Stacy and Rob's house that Mike's been working about 3 weeks already on this closet. We're going to do the shelving today. And hopefully they're going to be back from Vermont. They're going up to Vermont today. When they get back, their shelving will be installed. Oh my God, look, the closet. Oh my God. Oh, that came out nice. Mikey, you're the man. Cedar for that nice smell. Elf for shelving. Nice little seat for putting on your stuff. Wild hangers. And of course the mandatory. Light goes on when you open the door, just like a refrigerator. Very cool. What do you have to say for yourself, Mike?
I'm proud of myself.
I'm proud of myself. Oh my God, it looks great. Now it's only up to the kids. So the kids haven't seen this yet. They're in Vermont. This is a surprise when they get home.
Yeah.
We may even clean up the place a little bit. Clean up the floor anyway. Well, we got one of our other little projects done, the closet. Had a great Thanksgiving. It's time to get back to work now. The molding rubber hardened up fine, but I'm not going to work on that because what I'd like to do, my next goal here is to finish up Joe's wing so he'll be able to go home and work on it. And I got maybe 2 or 3 more days of work to do on it, but the next thing is to make up the horn. So let me clear the deck and get busy making up a horn here. There's a lot of figuring out to do on this. This is not as easy as it looks. This is one of the things we're going to probably spend a lot of time just figuring out how we want to have this horn attached to the back of the wing. Joe has decided to go with just a tweakable horn and brass lucky boxes. I need to get that. I think I have it already. It's over there. An envelope from Joe with all the little parts in it. So we'll start working on this today. Now the first decision I need to make is what is the total length of this going to be. It's going to be a little over 5 inches, 5 1/16. We'll try to center it, of course, center the upright, and we're going to have to remove this piece of wood. I guess just Zonasaw or get a blade in there and cut that out. Because remember, the horn is going to have to go halfway into the trailing edge. It's a little more complicated than obviously in a traditional ship. So we know we're going to need about 5 1/16 for the horn. And step one is, and of course I want to do a little experiment. I want to see we normally would put the legs back 90 degrees, but I'm going to try and see if we gain or lose anything by having the legs out at 90 degrees from the trailing edge, which is what I did on a B-25. Now the reason for that, there's a couple of reasons, is you get this side-to-side motion with any ship with dihedral and or the forward trailing edge sweep. So it may be better with the horn 90 degrees, may be better 90 degrees to the fuselage, but what I don't want to do is bend the horn up and then have to bend it back. I want to bend it once. If it's not right, just bend it the last little bit. So the first part of this is going to be to bend a piece of wire the thickness of 5 1/16 and with 90 degree legs to the trailing edge, not 90 degree legs to the fuselage center line. I'm not sure there's going to be any difference at all, but this is part of the experience of doing this wing with the dihedral and forward trailing edge sweep. So let me get a new blade, and step one, let's get that little piece of wood out of there so we can see exactly where this has to go, and then we'll center line everything up. Now what I did, I took away about 1/16 of an inch more than I have to, because I don't know how far out I'm going to have to shim the horn, and I don't want to start cutting in here. So the next step on here is to bend up a piece of wire where the two legs are 90 degrees to the trailing edge, and we'll see how that works out. And then I'm going to shim it out until I'm right on center, because I need to get the center of the horn on the center of the hinge line. I can't have it out in front, and I can't have it buried. So having this little extra material taken away is going to allow me to just get a piece of balsa and shim it right in position. And that's one of the tricky little things of dihedral swept forward planes. Now I wanted to show one of the ways that when I'm having to work alone, and I'm having to work alone right now, and if you don't have a helper, one of the ways you can get a center line on pretty accurately, what I'm trying to do is adjust the tape until I'm right on the center, and I have the centers marked on both ends. Now what this is going to allow me to do, I'm going to get a hyphenated center line on this, and the tape is holding it in position. I'm just working right up to the tape, which I don't know if you can see. Working up to the tape, and this is a 48-inch precision ruler, not a Home Depot ruler. Now I get one side on, and it's got the little hyphens, which I don't care about because we only need this for setting our hinges, but I want to get a real nice straight center line on there. Now the tape can come off, and I've got little hyphens. Well, filling in between the hyphens right now is not a big deal. And even if this step were difficult, you could use a piece of tape. Because without accurate center lines on this stuff, boy, especially a dihedral wing, and I'm just trying to really get these accurate, so when I cut hinge pockets I can get them right on center if possible. And the little hyphens that we do have, it's really not a big deal now, because we're only lining up with an 18-inch ruler. It's a piece of cake. Okay, so I have one, here's where it's going to get tricky. I have one wing, and I know it's exactly right here because I have it transposed. And I'm going to need to do the other side, and I'm going to need to get a center line across here. Well, first I'll do the other one off camera. Then I need to get a center line, and get a line, and that's where the wire is going to reside. And then I can shim it out or back it up depending on how this is going to lay out. And again, there's a little bit of give and take on this layout. This isn't a layout that is just going to be in 5 minutes. If this were an ordinary plane, we'd already have the horn installed. Now, one of the few problems that I've run into with, it's a personal thing. Karen likes to keep the house a lot hotter than I do, so what happens is I'm working in a shop that normally would be a little cooler, and of course I've accommodated her needs to have it nice and warm, but I'm used to working at this time of year in a flannel shirt, and about an hour into the day I'm cooking down here. My epoxy's drying in 2 minutes. Now, if we're looking from the back of this wing, and I'm going to exaggerate it, we have 3 pieces. And what this center line looks like, exaggerated, it's not, there's actually 3 center lines here. But it's really these 2 points, when we sight down that center line, that I want to have as accurate as possible, and I want that horn to come out exactly on center. Now, to do that, if we have the legs bent out, there's going to be a point at which it's too far in, and there's going to be a point when it's too far out. We want to capture it right at half of the wire thickness if possible, and that's why I think shimming it is a lot easier than just cutting a groove. Now, what we're dealing with, if you look at this from the top, totally exaggerated. This is from the top. This rotation, as this horn goes up and down, it's going to go back and forth. What we're going to do is in the edge of the flap, try to locate a piece of brass channel or a lucky box where this wire can actually, let's see if we got a piece of wire here. Oh, we got a Q-tip. Is just, as it goes up, as it goes down, it's going to rotate in that box but not change its dimension this way. Now, a couple of things that we learned from the B25, if you make this wire, the longer you make it, of course, the wider the lucky box has to be. So we only want to make it long enough that we'll be able to tweak the horns, because in this system, Joe is only going to have 2 choices. The choices are that he can put a trim tab on a plane, which is one of the choices always, or that he can grab this by the lucky boxes and just put a little bit of a tweak in it if necessary. And again, because it's a prototype plane, we don't know where that vertical CG is going to wind up. We're pretty sure the wing will come out straight, but vertical CG, you can never tell. That is because you never know how much paint is going to go on a plane, and we don't even know what our spinner is going to weigh, and a spinner is way above the center of gravity. So again, we want to leave ourselves a lot of choices here. And in laying this out, the next step is going to be to bend that wire and make a decision if we go 90 from here. And if it doesn't work out, then bend it 90 to the fuselage. And I'm not sure it really makes much of a difference or any difference at all. But this will be a good chance to check it. And then if I don't know, if I'm not happy, I'll just bend the wire. I'll bend another wire. I have plenty of wire. Now, a couple of things. Years ago, Jimmy Snyder used to make all our horns up, do all our brazing and welding. But keep in mind, here's what happens with music wire. Music wire is a very unique material. It has a tensile strength, it has a torque resistance that's almost at the top of the structural ladder of materials that we could afford to use. In fact, it may be at the top. But what happens with music wire, the joint that you make between here, and it's this joint, I've seen people that have used Stay-Brite solder and on smaller planes not had a problem. I would not recommend it. I've seen people that have used brass and just brazed it with brass. The problem with that, one of the problems that you have with that is it tends to detemper the wire because of the extra heat that you need. So what we have is we have a material. Let me show what this looks like. We have a material that we use from Harris Driver, 45% silver. What this means is it's going to make a joint that's almost impossible to break. And it's not going to require, we'll be able to do it with MAP gas, it's not going to require acetylene where we're going to possibly detemper the whole wire and turn this into coat hanger wire. So you always, the advantage of using an music wire is the torque resistance, and that it has a memory, it stays where you put it. Well, up to a point. It certainly isn't perfect, but if you were to do this and use coat hanger wire, well, yeah, you could tweak it easily, but every time you wiped off the plane, it'd be a problem. So, and then if you build up any slop in the lucky boxes, you got tweak and slop and everything's fluttering around. This joint here is very critical in making a horn. Now, the problem with this material, and you can see I still have this left over, a roll like this is very, very expensive. This, when we bought this the last time, it was a couple of $100, and I don't even know what it is now, and that was many years ago. You need to use this flux, and this flux tends to dry out even when you put the can, oh, it didn't dry out this time. But making a joint here, and I'm not a professional welder, I'd leave that to Scott Dinger or to Warren Walker or somebody, but to make a horn like this, I know roughly how hot it has to be. I know what the joint should look like when it's done. And of course I'll put it in a vise and test it extensively before I would allocate that to one of my planes. Now, when Jimmy did this, Jimmy had a beautiful assembly line. He had the exact right torch settings and all kind of temperature gauges or whatever to do this perfect. And it was nice. He'd do 200 or 300 at a time. It was nice. Tom Morris makes horns now, among other people. I think the Moon Brothers do, but I'm not sure. But we're kind of out of the horn business. We still have some of this material left over, but I don't have the jigs. I don't have any of the tooling. Jimmy had all the tooling, and John Brodak bought the punch press that made the uprights. So we're kind of at the end of our production run of horns. Here's another trap you can run into. If you look from the side view of a horn, and I have seen this a million times. If you have a horn and the center line of this is not 90 degrees to the center line, and we would check this with a triangle, of course, what happens? You induce exponential into it. You would automatically then have more up than down. Now there's a lot of ways of checking it, but I certainly wouldn't want to have the horn wire come out at 82 degrees or something, because what happens then in this dimension, you get way more travel, and in this dimension you'd lose travel by quite a bit. So this 90 degrees, when you're jigging up a horn, 90 degrees is like a critical part of the job. And additionally, once the joint cools, and we usually soak it in water, and that takes the flux to glass, the flux becomes glass. After we take that silver braze joint, clean it all up, solder in some bushings with Stay Bright, then if this needs a tweak to get it back to 90, it's okay to bend it 1 or 2 degrees, but I wouldn't want to start off with 10 degrees out. So there's a lot of little things all going on here at the same time, and we're going to try. I'm basically going to spend the rest of this day, and Karen's got the temperature up to 100 degrees. I'll be working in shorts here pretty soon. But anyway, these are some of the things to consider when you're doing a control system. And if you're going to put, if you're just building an R for a plane's going to take a month to build, you don't have to lose a lot of sleep over this. But when you're putting the kind of time Joe and I are putting into these projects, the effort, the energy, the time, you really can't trade any of this away. Just some thoughts, and I think they're useful. You know, I got this wire blender from John Brodak. I think it's K&S, but I'm not sure. I want to leave the legs a little bit longer than what I think they'll be, so I can trim them off. 2.5 would be a good starting point. I know we're not going to need that much, but. And I'm trying to put in less than a 90-degree bend with the wire bender. Now the idea here is, and that's less than 90 degrees. The idea is we can always bend this a little bit more, but the one scenario I don't want to have is I bent it way too far and then bend it back. I want to bend it only one time if possible. Of course, in the world of modeling, everything is is possible. And this is going to be quite a long horn. I think the only one that was as long or longer than this is the one I made for Paul Walker's B17 years ago. I look at that horn and I said, holy mackerel, and now I'm making one. Okay, so I'm allowing half of the distance of the wire for the bend. Let's just give it a little bit more. Again, we're going to underbend it, not overbend it. Do not, in fact, I can see this one isn't bent enough, but I can go and bend it a little bit more, but I don't want to bend it back. And I'll go get my 90-degree triangle and see how close we've got this. And by the way, these benders work great. I think they're about 20 bucks. Brodak has them in stock. Now just a preliminary fit to check the 90, and I can see I've got to go more. But I want to go a little bit at a time until I have 90. I don't want to go and then bend it back and do that tuna can thing. Now, just to see how close we can get this, part one of our little test, we got to get a little bit more. See, I'm sneaking up on it. I don't want to just go. Now, it took quite a few times to get this exactly 90. I think we're close right now for the first part of our test. Now the next thing is to make sure we have, I see we're off by a tiny little bit. Can put that in a vise. Can even tweak it by hand probably. A little bit more. So that the two legs are totally parallel. That's the next step before we solder the upright. I wish I had $1 for everybody that bought a horn that was unbent and then went crazy trying to get it bent and everything was, and then they ultimately you know, get frustrated by it. Okay, when we jig this up, we check first off that we're roughly at 90 degrees, and I can, by adjusting the wire and the vise back and forth, I can get that to hang at pretty much at 90 degrees, and we can, obviously we're going to check it and make sure it's perfect at some point in time. We're going to flux up the joint, do a stay silv is what they call it. We used to get this material through Russ Hunsberger too, who was a salesman for Harris Driver. But this is expensive stuff, relative even to the solder that we've had in the past. But the joint, if it's done right, it's unbelievable. Now the tip here, as when Jimmy used to do this, was get the flux on. Right at the point the flux turns to glass is right about the time that you want to put the solder on. And you want to put the solder on one side and heat the other side so it draws the silver right through the joint. Now sometimes if I don't get a good joint, I'll just bend another piece of wire. And sometimes it's your lucky day, and you never know. Using map gas. As soon as that starts to turn to glass, you know you've got a pretty good joint. Yeah, it's just starting to melt now. Trying to get the tip of the blue flame to be right there. Then heat the other side of the wire as something falls on my head here. Not sure what it was. And now to pull it through by heating this side of the wire. There we go. I see it coming through. Coming through the other side. If you have acetylene, this goes a lot quicker. Okay. Now, trick number 2. What fell down, by the way? Oh, a bunch of music wire. Trick 2 is to just use common sense. Let this cool normally. I'll go have a cup of coffee. Come back, then we're going to dunk it in water. Let it sit for 10 minutes or so, and the water will tend to get some of the extra flux off that's like glass. But we would not want to take this right now and run off and throw it in a bucket of water. We want to let it cool to room temperature. And you can usually tell if you've put solder on one side and it wicks its way through to the other side, it probably means you've got a good joint. Now once this is cooled, I can see that looks like a real good joint. Jimmy might be impressed here. But there's a lot more to making a horn than just setting up the thing and snapping them together, that's for sure. Not when you're putting this kind of time into a model. Now I'm going to dunk this in some water and then wire brush off as much of the flux as I can. Whatever doesn't come off, we'll get it off. I want to clean this up before we put the bushings in the horn. And most of the heavy flux falls right off, but I always like to get as much of the little, I don't know what you would call it, schmutz. Just polish this up just ever so slightly. You can see how if you work it, it'll take that right off. Even a wire brush is good for getting that stuff off. Now I'm ready to put the little pieces of brass tubing in there for bushings. I cleaned this up quite a bit, but now, of course, the whole reason for doing stay bright solder here, we don't want to put any extra heat on anything. The less heat, the better. As long as we get a shiny, clean joint, and it's always the best if you can pull a solder through from the other side, then you know you have the best, I think, the best possible joint. That's what Jimmy used to tell me anyway, and we had a no-hitter with his horns, so I have no reason to think he was wrong. And we just let that cool. And once that cools, let's stir this up. All the baking soda sinks to the bottom. And that neutralizes the acid. Now we can clean up the bushings, polish this up, we'll be ready to install it. And before I go any further on cleaning this up, I want to take a piece of music wire and see that we have a nice precision fit, but sometimes the solder will work its way in there. This will be ready to clean up. Yeah, we're good. We're good to go. Ready for a final cleanup and installation. But first we're going to take a coffee break, and I'll show you why in 1 minute. You're cooking me, and you're cooking, what are we having? Soup.
I made.
Oh my God, look at
Careful,
this.
it's hot. It's hot.
No, it's not as hot. Oh.
Lentil soup.
Lentil soup. What's in this pot?
This is Mexican minestrone.
Are we in business, or is
Look,
this just
look.
for personal use?
Look.
Yeah, I
Oh,
see.
that's using
I could smell it, but you know what? It's 100 degrees in the house. I'm cooking.
Well, you know,
I'm cooking, you're cooking.
it's 40 degrees outside, so
I'm
you
cooking.
decide.
I'm telling you, I came up to have a cup of coffee with you. But you think you could take a break from soup production, make me a cup of coffee?
If you take out the garbage.
Now, even though Karen's cooking me down here, I don't know why. On a cold day like this, a hot cup of coffee always tastes better than on a hot day. It's like magic. It's a magic trick. Now the next step on this is going to be carefully get this in place and get an idea, and I'm just estimating. Well, the first thing I have to do, I have to cut a little notch here so that I can have the horn slide in. Without that notch, I can't really get an accurate fitting. Now I know Joe has a doubler in here, so, and this is really no strength back here that we need to worry about compromising right now. And here's one handy thing: you could take a small X-Acto type knife, just to clear up the edges. This will be a lot easier to do now than once that part's in place. Now, after our first preliminary fit, I can see that by looking down this way, I can see I need to space this out maybe a 1/16 of an inch or so. I don't know for sure yet, but I know I've got the horn right on center for right now, and I know I've got my 90s pretty accurate. So the next thing is I'm going to make up just a dummy spacer that's going to push this away from the horn and act as a little bit of a reinforcement here, because we've cut away some of the material just to keep the horn nice and solid. Alright, I made up the little spacer. I'll tack glue that on. Everything's going to get tack glued here because I don't know if I need to make this 3/32 1/16, shave it down. I want to get exact. Remember, I need to come out, and right at this point I need to be able to look right down the center line of the horn when I'm done. Now, before the next step, I have to redraw the center line on that part. Remember, it's only tacked on because we don't know if we're going to make that thicker, thinner, or what's going to happen there. And there's got a lot of back and forth, and this is why I didn't want to start this on a session. I only had a half an hour to do this, because this gets time consuming. But once it's right, we're hoping we're going to have some real nice controls in this wing. And bulletproof more than anything else. Now with the center line back on there, now I'm ready to start fitting this up. Now I need to get a little brass, little bushings that are going to go on here, lay them out, and I just want to, again, just tack everything in place until I see how this is going to, the final movement is going to work out. Now, of course, the second one we do should go a little faster, a little quicker. We'll pretty much know what we have, but this one is just taking a lot of time. Now, I made these little pieces up out of little strips of brass. A tin can is fine, a fuel tank. But it's always difficult to get the setting that you want. And the reason I don't use tubing, I know one drop of CA can get in there somewhere down the road, and forget it. This is a system that I've used, and for better or worse, it's served me pretty well. Now, here's the big trick that I've used, is just I hold this in a pinch, and now I've got a little bit of a bind. Take a real thin piece of wire, put the wire in there, and pinch it over the wire. And now you'll see what happened is, now it's as free as a bird, even without grease. Now, same thing on this side. Once it's in place and I've roughed this up, I've etched it with a Dremel tool, this side looks pretty good. But I don't want any binding in there. No binding at all. Got my nice square tip pliers. Get a nice pinch on that. And usually what will happen, this is a great little trick, by the way. Let me just show this up close. Here's what happens. You can't get that last little bit of, let's do it this way, that last little bit of bend. It always wants to spring back. So you take the real thin piece of wire, or even a pin, and just gently pinch it. And now you'll see you can get it to be almost parallel. Now what I want to have happen is I want to have the bushings reside right inside the fuselage, the outer bushings. Now I'm going to make inner bushings on this also, but the outer bushing, and I'm just laying this out now to make sure I want to see how much room I have. Because what I need to do now is make 2 more bushings that are going to basically press up against the horn and keep it from any side travel. The only thing they do is keep the side travel. Now, yeah, I guess I probably could have made one big one on each side, but I just thought this would give me more choices. And the 2 in the center I don't have to account for, but this is the end of my fuselage. I didn't want the bushing sticking out over the fuselage. I wanted to leave this kind of so that I can finish it, because we're going to try to come up with some kind of a fillet in here. And I don't know exactly how that's going to lay out yet, so I'm going to leave myself the option. So let me make up 2 more bushings for the inside, and they'll just be to press the hold up on here, and we'll be ready to install the horn for a little test fit. Boy, there's a lot of work in a horn like this. And if you had to make a horn like this from scratch, it's 3 hours. It's ridiculous. I was trying to find a good break point to end this session at, because basically my lovely bride wanted to go look at Christmas trees today. So what I did, I just tacked this in, checked from each side that I'm right on center. From the top it looks like we got it. I've got 1 drop of thick CA just holding everything in place here. We've got plenty of travel, certainly not going to need more travel than that. Plenty of clearance. And the last thing is to just make sure I don't have any, when I hook this up, no interference on the edge of the push rod, which that's going to be perfect. Boy, that worked out. That worked out better than I could ever have expected. Wow. Now see, sometimes it doesn't work out. Every once in a while. What we're talking about is the clearance there. When I put this end of the push rod on, that we don't have any interference there. Well, and by using this system we have here, we're pretty much infinitely adjustable. So, okay, now what I need to do now is just put another drop of CA on here. And we'll make some little, well, we're going to end this session right now, in fact, because when it comes to Christmas in this family, Christmas is a big thing. And I know she wants to look at Christmas trees, so I always like to end a session like this right at a good point. I'll build up a little bond of glue there. The next time I get to work on it, make some little horseshoes of balsa wood to go over that, and maybe even wrap it with some carbon fiber. Now that whole horn issue, that was a big issue. It took up a lot of our time. It took up a whole session, in fact. But in this case, this is one of the things that in this model is totally different than all the other models we've done before. So luckily we planned ahead. We know we're not going to be able to rush through it. And next time we get to work on it, I'm going to work on the lucky boxes, the flaps, the hinges. But I'll just get these little pieces made. The 2 in the middle are only there to keep the horn from sliding. These out here to control the torque, like a torque tube. And out here we'll have lucky boxes next time we get to work on this. Now, Karen had a couple of things to do before, unexpected things, before we go out on our Christmas tree jaunt. So I thought I'd just maybe get this done here. I don't know if I'm going to be able to do this. This is going to take a little dexterity. I want to tack glue to carbon fiber. I put about 5 layers of thick CA to make what amounts to be a little horseshoe around it. Didn't need a piece of wood. I thought I would. This is always challenging to make this neat. And once one side is tacked on, I have all these pigtails. I'll flip it and do the other side. And I hope your family enjoys the Christmas holidays as much as we do. I just pull each one of these back up for the time being. This is really overkill, but we're looking for that infinite lifespan. I wish we were looking for it for our own bodies. But anyway. And that really gives this some support. Now, from this point on, of course, and we're not going to get a lot, this is definitely the end of it. But anytime I could sneak in a little half hour if you know, something comes up and I don't have to be the chef of the month here or anything. Now I can pull this up, this up. I guess we ought to get a new blade here sooner or later. And if you break one loose, it's certainly not a big deal. Just like this, I just need a new blade. This is just a good example of when one doesn't or pulls up like that. Here's the ticket. And that can happen from time to time. And this is the point at which I just want one thin drop of CA. The rest I'll do thick because I don't want to run the risk that someone's going to get down into that horn bushing and make me a major problem. And if you're not careful, it definitely can do that. I'll give about 3 coats of thick CA, sand this out a little bit, and that's all we're going to get done today. But if that horn's on there, there's no binding in it anywhere. When we're all done, 1 drop of oil will just be the weight of the horn is melting it full. We have to double check the horn angles, shorten these whatever amount we think we need, and then we start working on the flaps. Every time I work on this, I see more progress. And it's really coming around. Now it's really starting to get exciting. We're a week or so away from having this wing ready for the final sand out. Well, we're going out. We're going to do, oh, look at a red tree. Well, look at the red tree. We're going out. We're going to do a little walk, and then we're going to go try to find a Christmas tree. Leaves, leaves, leaves. Boy, if you like leaves, what a great time of year. I'm glad we don't have to rake leaves today. I'd rather go out and look at Christmas trees. And this is one of the things we like about living up this part of the country in the Northeast. The leaves, even though most of them have fallen off, there's still a few. There's still a few around our walking track even. This is our friend, the black squirrel. Now, we brought him peanuts, but we left him in the car. He's totally black. I never saw a black. Look at this guy. He looks like a baby, too. Hey, I brought you peanuts. I brought you peanuts, little guy. Don't give me that like you're made of me. So you might be wondering, how does Wendy stay in such great shape all through the winter? Running backwards with a camera duct taped to his head. I want to go tree shopping, baby. Trees.
First 3 miles, and then we tree shop.
3 miles. See, I got to pay for my tree shopping. 3 miles walking backwards.
3.2.
3.2?
Richard & Son.
Okay.
Holiday shopping is going to be a snap.
Holiday shopping?
Up to $320 in rebates.
As you can imagine, everything's packed. They want to come see Santa.
And perfect for my dad is a TomTom GPS
Looks like,
navigation system.
it looks like Statue of Liberty here. Well, we were out all day but didn't get a tree. But the people have already started putting up Christmas decorations, and boy, we love riding around at night after a hard day of shopping. Our neighbor to the back of us, Ellen. Yeah, he's got some nice stuff up there. It's Christmas season and we did not get a tree today. There's our big tree in the middle of town by the library. Oh, we're in a Christmas spirit, except we didn't get a Christmas tree. Now, I spent the whole morning raking leaves. Look at this yard. Not a leaf in the yard. Well, maybe a few that's still falling down. But Karen insists this afternoon we're headed out and we are going to get a tree. She's committed. We're out looking at Christmas decorations last night. She says, the hell with the Spitfire project. Get me a tree. And maybe she's right. I don't know. Oh, we had such a great Thanksgiving season, a pumpkin season. Boy, and we're glad we could share it with everyone. Hope you're just as lucky, but it's time. It's time to get ready for Christmas. See what happens at this time of year, especially if you're married to Karen. One season ends, and the other one just begins, just like the flying season ends. And you turn around, and it's building season. Spitfire season will end and it'll be time for the flying season again, but boy, 2007 has just been a banner year. In every way it can be a banner year. So my job here before we go out for our Christmas tree, clean off the porch because we're going to get ready for getting that tree. The tree at 93. Well, it took 2 days, but we finally got a tree. Finally. So now we can move on one day next week. We can, oh, the lights reflect in the floor. That's nice. We can get out our decorations. We're already in a holiday mood here, but there's still so much work to do in the shop. We're not gonna belabor this, but we will get this trimmed in the next couple days. Now we're gonna try to take advantage of a rainy day here. Get some more work done on Joe's wing. Definitely not going to do the tree today, but you can see the trees that had all the leaves on them, we're down to the nitty-gritty here, which usually means we should be getting some good cold weather, some rainy weather, some weather that we like to be in a shop drinking coffee, and most of all working on these planes. And I'm really never sure what it is about this building season weather, but you get up on a morning like this, that cup of coffee is so good. Unbelievable. Well, the first thing I needed to do today, I need to make the final attachment, get a couple more coats of thick and thin CA around this horn bushing, but you can see how nice this is just flopping around here just the way we want it to. I didn't want to put any oil on it yet, but the next thing I want to do is hook up the push rod here before we go any further. I want to make that adjustment. Let me show this up close. Now the first step is I want to get the bell crank in neutral. This is why I didn't glue this piece of sheeting on yet. Bell crank's in neutral. This is in neutral. And I want to mark where I want to cut the arrow shaft. Let me cut the arrow shaft right. Don't you love that? Now you can see why I wear these safety glasses at all times when using our little Dremel tool. Anyway, we've got this trimmed to the length we need now. Now the next thing on this, I want to bend up my little piece of wire. Once I have it bent, pretty much a replication of this end of it, but once I get this end bent, here's the trick to this whole thing, is to elongate the hole on this side just a tad. Just a tad. And what that's going to allow me to do is have an infinite adjustment by sliding that wire in a little egg-shaped hole back and forth just a little bit. I'll be able to get exact neutral on the bell crank at exactly the same time I have neutral on the horn. Same pretty much system we've used up here, back here. And as I look at, because this push rod is so short, you almost could, I guess, substitute, if you really wanted to, substitute a piece of 1/8" wire, and you wouldn't need the arrow shaft then, but I sure wouldn't just use a piece of 3/32 wire. But again, I'm sure this is a little bit lighter, but here's the trick with this whole thing is I don't want to get any tension on this. I want to have this an exact fit with no resistance, and I don't want any chance there's going to be any interference on the bell crank because that bell crank is off center. You know, we got a little piece of wire bent. It's etched on one side. We got some grooves cut in it. what I need to do is make sure I've got no interference on this. We've got a nice clean fit. I've got the little, let me show this up close just in case I missed this. This side, I've got little notches that I'm going to put the safety wire in after we put the washer or eyelet, whatever's going to confine that. And this end, of course, just roughed up with a Dremel tool so that the carbon fiber gets a good bite. But the secret of this whole system is when we attach this to the end, where this goes in, there's going to be a little in other words, I'll set neutral, and then I'll see if I need more up or more down to get equal travel, and I can elongate that hole. Once I've elongated it, then I can fill this with CA, fill this, and wrap this with carbon fiber. And it's the equivalent of having an exact adjustment that you would have with threaded couplers. But the good news is there's no $28 threaded couplers on the end of this, and this is a lot lighter. When Les was very surprised when he weighed up all the little parts that went into one of the 40 wings he was making, we found out they were considerably heavier than just making it out of the thin arrow shafts and wire. So there's a weight saving, and in my case, the thing I like the most is it's bulletproof. It isn't going to loosen up and things are going to pop off or anything, hopefully. So now what we want to do is get the belt crank in neutral. Again, that's why it's nice if you don't have this sheet on at this point in time. We want to get this relatively in neutral to start with. And I need to drill a little hole here. Let me get everything lined up in neutral where I think it's there. We're right. Because all I have to do is get this close right now. And right here is where I need to drill a hole. Of course, I'm going to drill it on a side. But that gives me a good starting point for where I'm going to line that up. And of course, before we do any attachment, I want to roughen this up. Anytime you're doing anything with an arrow shaft, roughen it up. Okay, now by just attaching this, we can get a rough fitting of if we're going to need to elongate this hole forward or backward. I guess I could put a little piece of tape on this just to hold it. Now I can just get a basic little look at if I'm close. Now I certainly have more down on the flaps than up. Whoop, as it slips out. So if I know I have more down than up, it means I have to elongate the hole that way. Let me do that. And then we'll be able to slide this in and incrementally get a fine-tuning adjustment on it. Now once I have a spot where I think I'm really accurate, and I think we are, that's neutral. Things here are right on the money. I just tack this with thin CA. And then what I'll do is just wrap it, get some carbon fiber tow, wrap it the same way I did on the other side. But before I do the wrap, I'm going to solder this washer and some safety wire on here, because that's going to heat the wire, and that heat isn't going to do this joint any good. So it's much better if I do the solder joint on that, then come back and wrap that end, and then of course verify that we have the same amount up and down, or very, very close to that amount. This way I just have not had any failures at all. It's relatively inexpensive. I think if I remember right, there was about $25 or $30 worth of hardware went into all these threaded couplers. But of course, if you like that and you're not opposed to it. Now in this case, a ball link here would have killed this. This would have come right up into the spar. Keeping that low on a belt crank gives us a much straighter line. Also significant is, you see the push rod is in line with, this isn't all cocked off to one side where we're creating side loads and twists and everything on this. So this should result in some really, really nice controls.